Okay, so today we will discuss about linear equations, quadratic equations, and polynomials, right?
Okay, sir.
Okay, let's start with linear equations. Um, Now, what do you mean by linear equations?
Linear equations are those equations that have a variable that is raised to the power of 1.
Okay, and how many variables can we have in a linear equation? How many possible
We can
variables?
have
Yeah, tell me.
we can have two variables. No, we can have as many variables we want.
Right. We can have as many variables as we want. Now, what does this mean? So let us look at a
Hmm.
simple example. Y equal to x plus 5. Is this a linear equation?
Sir, I can't hear your voice.
Y equal to x plus 5. Can you hear me now?
Yes.
Okay.
Y
Y
is equal to x plus 5.
x plus 5. Is this a linear
Yes,
equation?
that's a linear equation.
This is a linear equation, right?
Yes, sir.
Okay.
Hmm.
What does this mean? What does this
That the
mean?
var- that the values of y will depend on the values we put of x.
Correct. Value of y will depend on value of x. Is that
Hmm.
the only thing?
Hmm.
So if I write y equal to x square plus 5, here also the value of y depends on value of x. What is the difference?
The variable is raised to the power of 2. It's a quadratic equation.
What is the meaning? What is the physical meaning of that? What is the
That it can
difference?
have two solutions.
What is the difference between these two equations? In the first equation, for every value of x, there will be a single value of y, right?
Yes.
And what about the second equation?
We will have two solutions
No, what is the physical meaning of
of
that? Here, for two values of x, y will have the same value, right?
yes, sir.
So you can put -1 or +1, you'll get the same value of y. -2 plus 2, you can get the same value of y, right? Right?
Yes, sir.
Okay. And what about y equal to x cube plus 5? What happens there?
Three values of x and then the value of y will be the same. It's a polynomial.
Mm, okay. Three values of x will give one value of y. Is that true? We'll see that. Okay. So
Hmm.
for the time being, we'll talk about the first two. We'll come to the third one after that, right? Okay. So the physical meaning of the first one and the second one is that for every value of x, there will be one value of y, right?
Hmm.
Now, if I write y equal to 3x plus 2z plus 5w plus 10. What does this mean? Is
That
this
as we insert, this is a linear equation. If
okay?
we put the values of x, z and w will determine the value of y.
Correct. So the difference between the first equation that I wrote and this equation is that in the first equation, the value of y depends only on one variable, which is x. But here,
Hmm.
the value of y depends on three variables, which is x, z, and w. Right?
Hmm.
So, if we have to visualize this, we can plot this on a two-dimensional plane, which is x and y.
Hmm.
So,
Yes.
if I take the first equation, y equal to x plus 5, right?
Hmm.
So the graph would be what?
A, a straight line.
Mm-hmm. And how do we find that straight line?
We take out three values of
You,
x and y and then we plot it on the graph.
you can do it with two values also. So the simplest way of doing it is we put x equal to 0,
Hmm.
right? X equal to 0 means the y-axis,
Yes.
right? So for x equal to 0, y is equal to 5. That means if
Hmm.
this is y5, then this is a
Hmm.
point through which the straight line will pass. And
Yes.
next we'll put y equal to 0. So x is equal to minus 5. So y equal to 0 means the x-axis itself. And the value of
Yes.
x for that is minus 5.
-5.
So these are 2 points and we can draw the straight line using these 2 points.
But sir, if we take out only 2 points, then we
Hmm.
don't know it'll be a straight line or not because every line passes through 2 points. But if we take out 3 points, then we'll know that the 3 points lie on the same line.
You are absolutely correct. See, when you are given that it's a linear equation, 2 points will suffice. But
Okay.
if you are not given, then between 2 points there can be n number of lines, some curved,
Hmm.
some straight, right?
Hmm.
But if you are told
Yes.
that the equation is linear, then it has to be one line passing between 2 points.
Okay, sir.
Clear?
Yes, sir.
But if you are not given this and you are asked
Hmm.
to, draw a line between 2 points, that is impossible,
Hmm.
right? So,
Yes, sir.
so this is the difference. So here we are given that y equal to x plus 5 is a straight line or a linear equation, and the visual format of that would be a straight line in a
Hmm.
two-dimensional plane, right? And the
Yes.
meaning of that is for every value of x, there will be one value of y,
Yes, sir.
right? Now, if I plot the second one, how will I plot this?
You. Hmm.
Okay, let's take a simpler one, then we'll go to that. Let's take y equal to 3x plus 2z plus 10. How do I plot this?
So we put the value of x and z
No, physically, if I want to plot
to take
this,
out the value.
physically, if I like I
Hmm.
plotted y equal to x plus 5, right? So I want to plot
Hmm.
and see how this one looks. So y equal to 3x plus 2z plus 10 will be looking like what? So here we had two variables,
Hmm.
x and y, right? That's why we have
Yes.
used a two-dimensional plane. Here
Yes.
we have three variables, x, y, and z. So we have to use three coordinates. Right? So x, y, and z. This is 90 degree. Okay. So therefore we have to use three coordinates, and then we have to do exactly what we did in the previous case. So we will put x and
Okay.
z as 0 and see that the value of y is 10. So x and z 0 means x0 means it is y or z, right? Both are perpendicular,
Yes.
right? So x0
Hmm.
and z0. Z0 again means will lie on the yz yxy plane, right? So
Hmm.
in that we have to take the value of y as 10. So it will be somewhere uh, in there, in between the three, right? So similarly,
Okay.
we can take x equal to 0, y equal to 0, and z becomes minus 5, right? So again, there
Yes.
will be, it will be hanging somewhere there. So basically, this would not be a straight line, but this would be a plane.
Okay.
Okay.
So
So
the x-axis and z-axis are like the x and y two-dimensional, and then y is perpendicular
correct,
to
exactly,
x.
correct.
Okay.
To both x and y. So if
Okay.
so, the way to visualize is if you look at the walls of your room, you look at the floor
Hmm.
and look at any corner,
Hmm.
right? Look at any corner.
Hmm.
So it's perpendicular. So that's x and y. The floor itself is x and y, and from
Okay.
the corner, if you go up along the edge, that gives you the z-axis.
Okay.
Okay. So which means that let's say I take it like this. So I take one step in the x direction, one step in the z direction. So let's say x and z are the floor. Let this be z and this be y. So x and z are the floor. So one step in x and one step in z, and then I move up 10 steps.
Hmm.
Right. So this is how you have to visualize this.
Okay.
Okay. So in three dimension, when you plot, then it becomes a plane, not a straight line, right?
Okay.
Similarly, when we go to higher dimensions, there will be more similarly more you know axis that uh, needs to be drawn or
Hmm.
visualized to visualize the actual plot of the equation, right? So I just told you this. Just wanted to make you understand that linear equation doesn't necessarily mean that it will be a straight line. It can be a plane or any form of higher dimension spaces as well. But in the
Yes.
simplest form, it is a straight line. Okay, and we will mostly talk about straight lines. Okay, okay. Now let us look at straight line more carefully. So we take the same example, y equal to okay, let's say 5x plus 2. So if I plot this, I will put x equal to 0, that means y becomes 2, and
Yes.
y equal to 0, that means x becomes minus 2 by 5. Minus 2 by 5. So it will be a straight line like this,
Hmm.
right? Now, uh, what else can you understand from this straight line curve? So what are the things that we can understand? We can definitely understand that this would be a straight line which will follow this line that I have drawn, right?
Yes, sir.
What what about values of y which are greater than 5x plus 2? How do we find that out? So again, let's take x equal to 0. So y greater than 2, right? Y greater than 2 means all of this, right?
Yes.
Similarly, if I take x equal to 1 here, y is greater than 7, right? So x equal to 1 would
Yes.
be somewhere here, y is 7 is here, so it will be all this space. So this is the area of y greater than 5x plus 2. Similarly, y less than 5x plus 2 will be on the other side, right? So whenever you get confused with this, because there are problems involving inequalities and straight lines, right? We'll come to that. But if you get confused, the simplest way is just have a look at the inequality. Uh, just put x equal to 0 and check the value of y. So if it is greater,
Okay.
then it has to be greater than that. So all this side. And if it is lesser, then it has to be lesser than this. So it will be all this side. Clear? Because
Yes, sir.
in your exams, you will be very often asked to solve this kind of problems where you'll be given the equation of a straight line or two straight lines possibly, or maybe one straight line, and you'll be asked to find this area. You'll be asked to
Yes,
find
sir.
this area, or you may be given another straight line and you'll be asked to find this area, things like that, right? So when
Yes,
you
sir.
are dealing with such problems, right, always, you know, don't never get confused. Just look at the equation. If you're looking for less than the value, then just put x equal to 0, see what value of y you get, and just take the values that are less than that. That's it. Okay. Okay.
Yes, sir.
Now, let me show you another thing. So I have an equation of the form 2x plus 3y is equal to 50. Okay, where x and y are
Yes.
positive integers. Both are greater than 0. Okay, does this equation have a solution?
Yes, sir.
Can you solve this equation?
Yes, sir. 1 second. Um. Yes, sir.
How do you do it?
We can take x as 10 and y also as 10.
Hmm.
Then we get 50.
Okay.
Then we can take y as 4.
Hmm. Yeah, you're right, but we can't go with trial and error, right? So
Yes.
what we should do? So first we should write the equation by separating x and y. Okay.
Yes, then 50 minus 3y. That's
Right.
Uh,
So x is equal to 25 minus 3y by 2, right? And we know that x is an integer. So x will be an integer only when 3 by 2 is an integer, right?
yes, sir.
So that means y has to be a multiple of 2,
Hmm.
correct?
Yes, sir.
So what should be the lowest multiple of 2?
2 or 4 we can put.
No, we have to start from the lowest one. So the lowest
2.
multiple of 2 is 2 itself. So when y is
Hmm.
2, then x becomes 25 minus 3, which is 22, right?
Yes.
What is the next value of y that will be a multiple of 2?
4.
4. So when y is 4, this will be 25 minus 6, which
6.
is 19,
Hmm.
right? When y is
Hmm.
6, this will be 25 minus 9, which is
Yes.
16, right? So
Yes.
how long will this go? So now the question is how many solutions, how many pair of solutions exist?
Till we go till 24, because then
24.
no, wait. Um. Yes, one more pair we can have.
Okay. Before we do anything, let us try to see patterns in everything. Okay. What
Hmm.
is the pattern here? Y is increasing by 2
Yes.
and x is,
Decreasing by 3.
now you look at the coefficients of x and y here. X is decreasing by the coefficient of y and y
Hmm.
is increasing by the coefficient of x. Correct?
Yes, sir.
So what is the minimum value of x possible?
Um.
X can not go below 1, right?
Yes.
1 is the minimum value possible, right?
Yes.
But and what can be the maximum value of y? Okay, we'll take the minimum value of x itself. Okay, so x cannot go less
Hmm.
than 1,
Yes.
right? So what happens if I put 1 here? 1 is equal to 25 minus 3y by 2, right? So therefore 3 by
Hmm.
2y is 25 minus 1, which is 24.
Hmm.
Y is 16, right? So
Yes.
y cannot go beyond that.
Hmm.
Clear?
Yes, sir.
So y cannot go, see, I started off with the minimum value of y and I ended with the minimum value of x
Yes.
because we are told that both are greater than 0. So this is my boundary condition
Hmm.
logically, right?
Yes.
So therefore, now can I say how many values of or how many solution pairs are there?
3.
No. So it can happen from 2 to 16, 2, 4, 6, 8, 12, sorry, 10,
Okay.
12, 14, 16,
Hmm.
right? And the
Yes,
simple
sir.
way to find this out is look at the last value, which is 16, minus the first value, which is 2, divided by the common difference, which is 2 plus 1.
Hmm.
That means 14 by 2, which is 7 plus 1, which is 8 pairs,
Yes, sir.
right? And this would be the
Hmm.
same if you do with x. So 22 minus 1 by 3 plus 1.
Yes.
Okay. So,
Yes, sir.
so this is another very common question in exams, where they ask
Hmm.
you to you don't have to find the answers to every pair, but they'll just ask you how many pair of solutions will exist, right?
Hmm.
It might be a simpler one, like 2x plus 3y is equal to 20, right? So the logic is this. So you have to um, take the x and y on two different sides and see for what values of y x uh, takes integral values. Okay.
Yes, sir.
Okay. Now tell me, if I have a equation um, like 2x plus 5y is equal to 17, and 3x plus 8y is equal to 22, right? How many solutions will exist?
For each of the equations, there'll be infinite. We can put as many values as we want.
No, this is the problem. So if I have one equation, 2x
Hmm.
plus 5y equal to 17, with conditions, of course, x and y greater than 0 or something like that,
Okay.
then we can find the values of x and y, like I showed. But
Hmm.
if you are given two equations, there will be only one pair of solution, only one pair, because it will be the point of intersection of these two lines,
Yes, sir.
right? And why were we getting so many solutions in the earlier case? Because in the earlier case, we had taken, this was our line, and we had taken x and y greater than 0. So
Hmm.
everything falling in this space, and the total was, let's say, 50. So all these points,
Hmm.
right? So all these integral points we found out in the previous solution. But in this case, we are given two pair of lines, one like this, one like this. So wherever they intersect, that will be the solution pair,
Yes.
right? Now,
Yes, sir.
if I have four variables, uh, x, y, z, and w, how many equations do I need to have one pair of solution, one unique pair of solution? How many equations are needed?
Two equations.
How many variables are there?
Four.
So for four variables, we'll need four equations. For two variables, we'll need two
Two
equations
equations.
for unique solution.
Okay.
So the number of equations will have to be equal to the number of variables. Clear?
Yes, sir.
Number of equations should be equal to number of variables. Okay, now let's take an example. Let's say 3x plus 4y is equal to 12 and 12x plus 16y is equal to 48. How many pairs, how many solution pairs will this have?
This will have infinite solutions.
Why?
No, wait. This is a um
You're right. It will have infinite
this yeah,
solutions.
because so we were told this in school. So 3x plus 4y is equal to 12 is um x1 plus y1
Hmm.
my minus, like 12 will come to the left hand side and will become minus, so minus c1 is equal to 0 is in the standard form, and then in the same way we make that to the second equation, and then we put x1 upon x2,
You don't have to do all
which
of that.
becomes
There is a very simple thing. You just have to notice the equations.
yes,
See, in this equation, I can divide this by 4. If I divide this by 4, I will get
it will
3x
become
plus
the same equation.
4y equal to 12. So, which means that if the second equation is a multiple or a divider of the first equation, then you will not have a single solution. So that means we have to have two um, distinct values or two distinct equations, right? We have to have two
Yes, sir.
distinct equations. Okay. Uh, what if? Okay. What if I have the equations 2x plus 3y is equal to 6 and 4x plus 6y is equal to 9. Will I have a single solution here?
No, zero solution. This is a parallel line.
Correct. So whenever you have the same equation or the slope is equal, the slope is the same, then you will not have any solution or there are infinite solution, right? So one line is like this, the other line is
Yes.
like this,
Hmm.
right? So yes, you are right. So therefore,
Yes, sir.
we have to always check for the ratio of these two numbers.
Hmm.
Okay, so this is a very tricky question that comes in the exam, that what would be the value of x and y, right?
Yes.
And your options would be
Yes.
infinite, and some values of x and y will be given, and one option would be infinite. So the answer would be infinite,
Hmm.
right? Okay. Uh, Now, uh, okay, let us go to quadratic equations. So as I said, quadratic equation means that for every value of x, sorry, every two value of x, there will be one value of y.
Hmm.
So in general, it can be uh, like this, right? Y equal to x square plus
Yes.
x plus 1. Now,
Hmm.
what can we tell about this equation? Okay, before I go into this, let's take the
Hmm.
sim let's take the simplest one. Y equal to x square. This is the simplest one. So what can I tell about this equation?
two values of x will have one value of y. Like,
What else? That is correct. Two values of x will give one value of y. What else can you tell me from this equation? The second thing that is evident from this equation is y cannot be negative.
yes,
Why?
because the square of every number is positive.
Square of every number is positive. So therefore, the graph will look something. Okay, in order to draw the graph, we will take x equal to 0, so y equal to 0. So this is
Yes.
one point on the graph, right? Now we can take any other point. So x equal to 1, y is equal to 1. So 1, 1. X equal to 2, y equal to 4. So it goes exponentially. So the
Hmm.
curve will be like this on this side and like this on this side. Exactly similar, right?
Yes, sir.
So this is y equal to x square, right?
Yes, sir.
So now if I talk about y equal to x square plus x plus 1, then how will the curve look like?
For this, x square plus x plus 1, to find out values of x, we'll have to do middle term splitting, right?
Yeah, you can do that, but I'm not asking
Hmm.
for the solution. I'm just asking
Hmm.
for the graph.
It will be a straight line.
Hmm? Never square. So as I said, always put x equal to 0 first. Whatever is a graph given. Okay. So if
Hmm.
x is equal to 0, y is how much?
0.
Huh? Look at this. X equal to 0.
Yeah.
So
Then y is equal to
x square is 0, x is 0. But
hmm,
what about 1?
y is 1. Yes.
Right? So y will be 1. So x0, y1 will be a point on the graph. Right?
Hmm.
Next what?
We can take x as 1,
Yes.
then y will be equal to 3.
Okay. Next.
Then we can take x as 2,
Hmm.
y will be 7.
Okay. Okay. So the graph will go like this on this side. What happens on the negative side?
Mm. So if we take minus 2, then y will be 3.
Minus 2 means 4 plus 1, 5 minus 2, 3, yes. Minus 2, y is 3. Okay.
Yes.
Why did you
We
take
can
minus?
take minus 1.
Yes, take minus 1. Go with
Hmm.
increment of 1. So if x is equal to -1, what is the value of y?
0.
0?
No,
Sure.
wait. 1, 1.
1.
Hmm.
So this was y1 at x equal to 0, and at x equal to 1, this comes back to 1, right?
Hmm.
What happens in between these two? We can understand that the graph will go like this, but something is happening
Hmm.
in between. So take a negative fraction, half. So x equal to minus half. Okay.
Hmm.
Y is how much?
1 upon 4. No, wait. 1 upon 4 minus 1 upon 2 plus 1, which will be 3 upon 4.
3 upon 4. Correct. So we can understand that the graph will come down below 1 and be
Hmm.
something like this, right?
Hmm.
Now, the big question is, will the graph touch the x-axis? Because if it touches the x-axis, then there will be one solution,
Yes.
right? So the question is,
Hmm.
will the graph touch the x-axis?
Hmm.
Obviously, we cannot, keep
Well,
on plotting every point. That is not feasible,
yes.
right? So how do we figure this
Hmm.
out? Okay, let us look at the logic now.
Hmm.
Okay, let us take any general form of the equation. I took a particular form, so I will take a general form. Ax square
Hmm.
plus bx plus c, right?
Yes.
This is a general form of the equation. Okay, and we can write this as a into x square plus b by ax plus c by a. Can I do this?
Yes, sir.
This I can write as x square plus 2 into b by 2ax plus b by 2a whole square minus b by 2a whole square plus c by a. Why did I do this? See, I am trying to find out the logic of whether
Hmm.
this graph or this
Well,
equation will have real roots, right? Which means that whether this graph will intersect the x-axis, or will it just touch the x-axis at some point, or will it be above x-axis? These are the three possibilities, right?
hmm.
Correct. So
Yes.
if it is case 1, so let us say this is case 1, then I'll have 1 and 2 roots, or two point of intersection means two roots, right? If it is a second case, then I will have only one root,
Hmm.
right? And if it is the third case, then I will not have any roots because it is not touching the x-axis at all,
XX. Hmm.
right? So what I'm trying to do is to logically arrive at a situation which will tell me whether when each of these cases will happen, right? So
Yes, sir.
I'm trying to build a square function because a square is always positive,
Yes.
right? And how did I do it? I had a x square here, I had that x here, and a b by a, and I know that x plus a whole or x plus whatever x plus k whole square is equal to x square plus 2kx plus k square. So I'm trying to
Yes.
build this term 2k. So I brought 2 here. So I cannot change the term. So I had b by a. So I had to bring a 2 here so that the overall term remains same,
Hmm.
right? And because
Yes.
I brought b by 2a, I had to bring in a square of that to make this a complete square.
Hmm.
And then I subtracted the same term so that overall the expression doesn't change.
Yes.
Clear?
Yes, sir.
So therefore I can write this as x plus b by 2a whole square plus c by a minus b square by 4a square.
Hmm.
Right? Correct?
Yes, sir.
Now I can simplify this: a into x plus b by 2a whole square plus a into c by a minus b square by 4a square. So I can take
Hmm.
one a out in the denominator. So this
Yes.
become x plus b by 2a whole square plus a by a will cancel out. So
Yes.
c minus b square by 4a, right?
Hmm. Yes, sir.
Okay. Now why did I do all of this? Because I wanted to find out the condition under which this curve will intersect the x-axis,
Yes.
right? Now look at it. Look at this carefully. For any value of x, for any value of x, x plus b by 2a whole square will always be greater than 0, right? Square term,
Hmm.
right? And
Yes, sir.
I'm considering the curve like this. Okay, so a is positive, a is greater than 0. The coefficient of x square is greater than 0. If it is negative,
Yes.
then the curve will look like this, right? So the logic will remain same,
Yes.
but we will first we'll establish this for a greater than 0, and then we can prove it for the other way. So for a greater than 0, that means for these set of curves, right, the first term itself will always be greater than 0,
Hmm.
right?
Yes,
First
sir.
term itself will always be greater than 0. Now, for the given equation to have real roots, it has to either touch the x-axis or intersect the x-axis, right?
Yes.
So there are two
Hmm.
possibilities. So that means if it is intersecting the x-axis, then the minimal minimum of the minimum value of the curve will have to be negative,
Yes.
right? And here the
Hmm.
minimum of the curve will have to be 0,
Hmm.
correct?
Yes.
Right? So let us take the first case first. So if this has to be negative, if this point has to be negative, right, then this whole term
Yes.
has to be negative,
Hmm.
right? But the first term will
Hmm.
always be positive.
Yes, so the
So,
second term will have
so the second
a
term
negative.
has to be negative for this to have real roots.
Hmm.
right? So which means
Yes, sir.
c minus b square by 4a has to be less than 0 for this to have two real roots,
Hmm.
right? Or c is
Yes, sir.
less than b square by 4a. I just bring this term on the other side. C is less than b square by 4a.
Yes.
So that means b square is greater than 4ac, right?
Yes. Yes.
Or b square minus 4ac is greater than 0. You might have gone through this this is the determinant of the quadratic equation, which has
Hmm.
to be greater than 0 for the roots to be real. But this is the logic
Hmm.
why it is so, because this point has to be negative,
Hmm.
and from there we can derive that b square minus 4ac has to be greater than 0, right? what happens
Yes, sir.
what happens if b square minus 4ac is equal to 0? That means this term will become equal to 0, right?
Then the equation will remain positive.
The equation will remain positive or 0.
Hmm.
This is greater than equal to 0. So this is greater
Okay.
than equal to 0. So the
Hmm.
expression will be positive or 0,
Hmm.
right? Now
Yes, sir.
if it is positive, then we will have this case 3. Clear?
Yes, sir.
If it is positive, then we will have the case 3,
Case 3.
right? And if it is 0, then we will have case 2. So if it is
Yes.
0, then x is equal to b minus b by 2a, because a is greater than 0, that we have considered. A cannot be 0, right?
Hmm.
If a is 0, then the equation doesn't exist, right?
Hmm.
So a is greater than 0. So this term has to be equal to 0. If it is equal to 0, then x is equal to minus b by 2a, which would be the solution for unique solution for this equation. Clear,
Yes, sir.
right? And that can only happen when b square is equal to 4ac. When b square is equal to 4ac, then this term becomes 0, and this term, if it has to be 0, then x has to be equal to minus b by 2a,
Hmm.
right? And if this
Yes.
term is positive, which means b square is less than 4ac, then we will get the third case.
Hmm.
Clear?
Yes, sir.
So this is the logic, and have you done quadratic equations in school?
Yes, sir, but only to take out a few solutions and plot the graph.
Yeah, but have you not gone through the determinant part?
No, sir.
Okay, so this is a very common thing that you have to use over and over again. I mean, this is a
Hmm.
basic concept of any quadratic function, right? So it is right. You are right. It comes from the graph itself, and the logic is this.
Yes, sir.
Okay, and the reason I showed you this is because I'm going to uh, use the same logic when I go to higher degree polynomials,
Okay.
right? So the logic is that for any curve to have real roots, it has to intersect the x-axis. That is the logic. And in order to intersect the x-axis, the minima has to lie below the x-axis,
Yes.
which means the minima has to be negative. This is the logic, right? So now come back to the expression that we were or equation that we were dealing with. So we had y equal to x square plus x plus 1.
plus x plus 1.
Now tell me how this curve will behave. We found out that the curve was something like this, and it, I mean, between
Went to
minus 1,
3/4.
between minus 1 and 0, we know that the curve is coming down, but we don't know whether it will touch the x-axis or not. That is the
Yes.
problem. So now tell me whether it will touch the x-axis or not. So think of this as
Hmm.
ax square
Yes.
plus bx plus c,
C.
right? So
Hmm.
what are the values of a, b, and c here? A is the coefficient of x, 1.
Yes.
B is the coefficient of, sorry, A is the coefficient of x square, B is the coefficient of x, 1,
Hmm.
and C is 1,
Yes.
right? So B square minus 4AC is how much?
Minus 3.
Minus 3. So that means B square minus 4AC is negative.
Yes.
So will the curve touch the x-axis?
Yes.
No. B square minus 4AC has to be greater than 0. Greater than, if it is greater than 0, then there are two roots, then it will intersect. If it is equal to 0, then one root it will touch, and if it is less than 0,
Hmm.
then no roots, or it will lie above the x-axis. So it will be like this.
Okay.
Clear?
Yes, sir.
Again, this is a very important concept, because you will be asked questions on quadratic equations, where how many roots it will have and things like that, whether how many zeros it can have, or whether it will touch the x-axis or intersect the x-axis, right? So the logic is
Yes, sir.
this, right?
Hmm.
The logic is this. So all you have to remember is this particular thing, b square minus 4ac. Always treat the equation as ax square plus bx plus c, and put the values of a, b, and c in this, and see whether it is negative, changes, or positive.
Hmm.
Yeah. Okay.
Yes, sir.
Any doubts on this?
No, I understood. I thought that when it's negative, it'll go, it'll touch the it'll have to, but it's to have. I understood.
Okay. No issues. Okay.
Hmm.
Now let us look at the higher degree polynomials. And I've seen questions in CBSE coming around that. Um, so let's say I have a curve y equal to 4x cube plus 3x square plus 2x plus 1, right?
Hmm.
So how many roots will it have?
3.
How can you say 3?
Because we take the degree of the highest variable.
Now let us look at the graph. What can happen? Like, see, whenever you talk of roots, right, always visualize in the form of a graph. That makes it very easy for you to understand. Okay, like for example, when I gave y equal to x square plus x plus 1, looking at this,
Hmm.
the first reaction is, since x there is an x square, there will be two roots, right?
Hmm.
But when you look
Yes,
at the
sir.
graph, you realize that there can be three cases,
Hmm.
right? And whether it will have roots or not will depend on the coefficients of x, x square, x, and the constant term, right?
Hmm.
Right?
Yes, sir.
Now, when we deal with this kind of equations, cube or to the power 5, what will be the
Hmm.
what will be the form of the graph? Now again, let's start with the basic one, y equal to x cube. How will this graph look like?
It will be a curve on both the sides.
Right. So at x equal to 0, y is equal to 0. This is the first thing.
Hmm.
So it will pass through this point.
Yes.
So when x equal to 1, y equal
Hmm.
to 1. When x equal to 2, y equal to 8. So it goes very fast, right?
Hmm.
And similarly, like this on the other side,
Yes.
right? Now, how will this curve behave?
Sir, won't it go on the positive side? Because y can't be negative. Acha,
Why?
x cube.
This
X cube. Okay,
this is
okay,
cube.
okay. I thought you wrote it. Huh. Hmm.
This is cube,
Yes, yes.
right?
Yes, sir.
Okay. So let me again, let me just digress for a while. So you remember
Hmm.
we were discussing odd and even powers yesterday.
Yes, sir.
So uh, positive, any positive number to the power of any even number is positive,
Hmm.
right? Even
Yes, sir.
or odd, right?
Hmm.
Is positive, right? Any negative number to the power an even power will be positive,
Hmm.
and negative number to the power odd will be negative.
Yes.
So whenever you see an expression of the form y equal to x, or y equal to x cube, or y equal to x5, or y equal to x to the power any odd number 17, all these will have both positive and negative values, right?
Yes, sir.
When x is equal to 1, that means y equal to x, the curve goes like this. X equal to 3,
Hmm.
x cube, the curve goes like this. X17, the curve will go like this. Okay, this is how it will
Hmm.
happen, right? On the other hand, when y is equal to x square, x4, x6, all those cases will have the curve on the positive side for
Hmm.
both values of x, right? Okay. So coming back to this particular case of 4x cubed plus 3x square plus 2x plus 1, right?
Yes,
How do
sir.
we deal with this? Okay. Again, uh, we can understand that there will be different cases like we saw for the quadratic function, right? In the
Sir, I
quadratic
can't hear you.
in the quadratic function, we saw three cases, right?
Hmm.
One was above the x-axis, one was touching the x-axis, one was intersecting the x-axis, right? So there were
Yes.
three cases. Here also there would be different cases. What are those cases? Case 1 is the curve can go like this. This is case 1,
Hmm.
right? So it will have both a minima as well as a maxima.
Okay.
Okay, these are local minima and local maxima, but they will have, the curve will have a minima and a maxima, right?
Hmm.
Now, okay, can you tell me why this will have a minima and a maxima?
I don't know, sir.
Okay, let us again look at these two curves, y equal to x cube and y equal to x square. Okay, now if I plot these two curves individually, what
Hmm.
will I see? For y equal to x cube, the curve will go like this, and for y equal to x square, the curve will go like this. Correct?
Yes, sir.
Right? So it is as if I am superimposing x cube and x square. Both are there,
Yes.
right? So that is why it is as if curve is divided into two parts. One is behaving
Hmm.
like the um, cube function, and the other one is behaving like the square function. You get it?
Yes, sir.
So the the first and the last part is behaving as a cube function, and the part
Hmm.
in between them, this is behaving like a square function, right? You see,
Yes.
this represents a quadratic equation. This also represents a quadratic equation, but these two represents a cubic equation. So it is a combination of both here,
Hmm.
right? So this is one possibility.
Yes.
The other possibility is that the curve can do like this, or it can do like this, right?
Hmm.
It can do like this.
Hmm.
However, however, what it cannot do is this. It cannot just touch, go up and come down. This is not possible. Okay, because I cannot explain why this is not possible, because it requires a little bit of higher mathematics to understand this. So I'm not going into that right now. But just understand that
Okay.
there would be three cases. One could be like this,
Hmm.
second could be like this, and the third could be like this, right?
Okay, sir.
So if I take the first case, how many roots will be there? Case 1, this curve. How many roots? Let me just redraw this. It's too messy. So case 1, I have a curve
Hmm.
like this. How many roots will it have? Roots means
Hmm.
zeros.
Yes.
That means points
Solutions.
of intersection
Hmm.
with x-axis. So this is x, this is y. So how many
Yes,
roots?
sir. One.
1. Because it touches or intersects the x-axis at one point only. Now, case 2, it does like this. How many roots?
3.
Correct. 1, 2, 3. And case 3, it goes like this. How many roots?
1.
1.
Hmm.
So that means this can have either one real root or
Hmm.
three real roots.
Yes.
Okay, but it will always have at least one real root. See, in all three cases, it is touching or intersecting the x-axis at least at one point.
Yes, sir.
Okay, so if you are asked in the exam that what is the minimum number of real roots that this equation will have, then the answer will be 1. Okay, and
Yes,
maximum
sir.
would be 3,
Hmm.
right? Maximum would be 3.
Yes, sir.
Okay, now in this case it is very difficult to derive what I did with this the quadratic equation, um, to show the condition for which this will happen. Okay, so in the earlier case, what I had done was I divided the equation into two parts, one with a square plus one with a constant term, and then
Yes, sir.
because this can never be less than 0, so I played with this term, right?
Hmm.
Here I cannot do that because I have a cube,
Yes, sir.
right? However, with with calculus, it can be shown exactly where this curve will, I mean, under which condition this curve will have a real root or three real roots. Okay, but that is not
Yes.
part of your syllabus, so I'm not going to get there. Okay, but conceptually, this is what it will look like. So it will have,
But
yeah,
so how will we realize how the graph will be like the curves you've made and the places where it's touching? How will we realize like what the roots are and how the graph will look like?
correct. So the that will depend on the coefficients, right? Let me
Hmm.
let me clear this. So again,